Hi, this is Christopher Boucher, and I'm going to review a simple linear regression problem. And this problem is overly simple because we're doing it by hand and then we're going to run it through the calculator. So normally you would have more data points for this type of problem. Okay, we'll get started here. This is a basic, like I said, just a made-up problem. Super simple. A nonprofit group is conducting a retrospective study to see if the number of cars an individual owns in a year may be correlated to the number of parking tickets one receives per year. With the related data below, find the least squares line r in r squared. So we have this would be technically our x column, and this would be our y column. And then what I did was I pre-did some of this because it's kind of a lot of writing, which can get kind of messy doing it all by hand. So I pre-wrote some of these columns, and I'll explain how you do this. I'm also using a black pen instead of my usual marker just because of the it can get a little bit messy with all of the writing on this one. Okay, so this data down here, x and y, it's the same as these two columns right here. So this is the sum of the x. This is the sum of the y column. And then this is the average of the x. And this is the average of the y. So that's just the sum divided by the number of rows, which is 1, 2, 3, 4, 5. So 47 divided by 5, and then 20 divided by 5 is 4. And then what we do is we multiply the x and the y, and that's what this column is right here. And then the sum of that. And then the x squared, that's what this column is right here. And then the sum of all of the x squared. And then y squared, and the sum of all of the y squared, and that's 507. So that's what all of these are right here. So I kind of pre-did some of it. I want to focus on the math down below. That's kind of the goal of this video. Okay, so this is the way you do it. You would set it up. You have this data here, and then you would go and you'd set up these columns because you need this data. Primarily, you need these right here, the sums of this data, and then you need your mean essentially, and your y hat, which is the mean of the y's. So that's how we do that. Like I said, we'll do it by hand, and then we'll look it up on the calculator. And you can also do it on Excel. Okay, so for the first one here, let's see, we want to fill in our pieces for this. So let's see, it would be our sum of our xy, which is right here, 220. Subtract this one. So I'm going to draw this out. And we end up with our 20 multiplied by 47. And then that's over n, which is 5. And we end up with 220 subtract 188, and that equals 32. Then for the next one, we want our sum of our x squared. So our x squared is right here. So that would be our 106. Subtract. And then let's see, it is our sum of our x, and then we square it. So it's not the same one as the sum of the x squared. So that is our 20 squared. So that's this one squared. And then down below it's 5. So that is, just simplifying, 106 subtract 80. And that's 26. I'm underlining the values that are important out of this. Okay, the next one, the sum of the y squared. So the sum of the y squared would be the 507. 507. And then the sum of the y squared, once again, it's not the y squared, it's the sum of y, and then we're going to square it. So that would be, let's see, 47 squared over 5. So simplifying, 507, and then 441.8, which equals 65.2. Okay. Once we have this calculated, we start plugging in, and it's really easy from here on out, in my opinion. Okay, so for our b, and our b is essentially our slope in this line. So our b is going to be, let's see, it is SSXY. So we have SSXY, and that is 32. So that's 32. And then it's going to be over SSXX, which is 26. And with that math, we end up with 1.2307. On this, I like to go out pretty far with the decimal places, only because when these numbers are large, it's not as big of a problem on this one, but when these numbers are large, we can lose some precision when we're doing this. Okay, so for the next one, we have y hat, and y hat is right here, 9.4. Subtract our b, which we just figured out, which is 1.2307, and then multiplied by our mean, our sample mean, which would be, or our mean of our x for this one, which would be 4. And the answer for that one is 4.4772. Okay, we have a lot of stuff we can start. Now we can put together our line. So our line is going to be our a value, 4.4772 plus, and we leave this like we're not gonna simplify or add this line. This is our line, which represents the different pieces represent. Take for instance where the line crosses our y axis. And the b represents our slope, and the x is what I kind of call the incrementer. It's the value where if you increase your x, it's multiplied by your slope, and then you end up with your line either increasing or decreasing along that plane. So our b was 1.2307, and then x. Make sure we're right on that. Yes, we are. Okay. So this is our line right here. Okay. And now we're going to go and solve our r. And our r is 32, which is our SSXY. And then the root of these two multiplied together, SSXX. SSXX, which is 26 multiplied by SSYY, which is 65.2. And when we work that all out, we end up with 0.7772. And then you can square this, and you will end up with the answer, but the other way, the actual calculation is this. So we end up with b, and our b value was 1.2307 multiplied by SSXY, which is 32, and then SSYY, which is 65.2, and the answer for that is 0.6040. So we have, this is our line right here. This is our r. and this is our r squared. Okay, so the r right here represents the strength of the correlation, so it's 0.7772. So a perfect correlation is 1, and a perfect negative correlation is -1, and then this is our line. We could actually plot everything out. So now let's take a look at the calculator. Calculator, I already have some of the values set up here. So what you would normally do is you would go into stat. I need to turn on, okay, go into stat, and then you go into edit, and when you click enter on the edit, it ends up going into the list editor. Oh, I had them set up on my other calculator. That's okay. We're going to put them in. So 1, enter, 2, enter. I'm going to move this over so I can just read the screen. 1, enter, 2, enter, 4, enter, 7, enter, 6, enter, and then go over, and then 5, enter, 7, enter, 12, enter, 12, enter, let's see, so 15, enter, and 8, enter. And as I've mentioned before, this is a very basic example, so normally we wouldn't have such a basic one, but trying to show the method in this, we want to use basic calculations. Now I'm going to do second quit, and that gets me out of here without accidentally putting in any data. So second quit, and now we're starting over. I'm going to move this out of over here just a little bit. Okay, now I'm going to go back into stat, and I'm going to go over one click to the right, and now we're going to go down. And now this one right here is similar, except it's not formatted the way that we usually like. It has ax plus b. We want a plus bx, and that's the number 8 on this option. I have found a couple calculators from one of my students that said that he actually didn't have, it's amazing how some of the calculators don't have some of these things. So it's possible that some calculators don't have this. So push enter. And now we have list 1. This is a default setup. List 1, list 2, which our X list is L1. Our Y list is L2, so we're all set. Do not put anything in the frequency list. It will mess up the calculation. And then there's some other things we can do with the store regular expression when we graph, but we're not going to do it right now. Now I'm going to do calculate. And the answer that I get is, should be our A value, which is 4.477. It's a little bit different because the calculator is super precise, but 4.4772 and then 1.23. One thing I'm going to do real quick, I'm going to go back in and do diagnostic on, and it'll give us our R's. So this is what happens if you don't have diagnostic on. So I'm going to do second quit real quick, and then I'm going to do second catalog, and I'm going to, it's in the alphanumeric mode, so I'm going to put in D, which is hard to find here, and then I'm going to go down to diagnostic on. This is something that gives us the R's, R and R squared. Now diagnostics on, and I'm going to go right back. I know I'm going a little quick, but I'm going to go right back to where we were, number 8 on the calc menu. Our data is still in there. It's going to give us our R values, our R2 and R, and our R 0.772, and our R2 is 0.6040. Pretty darn close on these. They're identical. So that's how you do this by hand, and the simple linear regression. And this is how you do the simple linear regression on the calculator. Thank you.